To start off our lesson, I'd like to go back and do a little review. We're headed for a chapter test, so let's see what we did recently that'll help us to prepare for the test. We talked about arithmetic sequences, and we looked for patterns, and we also looked to see if we could find that common difference and complete the pattern. As I'm looking at these, I want to find if there is this continual, constant change from term to term, and I can find out what that change is by subtracting successive terms. And if I subtract 18 from 21, I see that there's a difference of 3, so I'm going to get a plus 3. I'm going to see that from the next and the next, and you want to be sure, so don't stop at the first one and say, okay, I found it. You want to be sure that it's the same and it continues throughout. And then to continue the pattern, I would add 3 repeatedly, and I'd find the common difference, which was 3. On to the next. Again, looking at these numbers, 6 to 13, 13 to 20, 20 to 27, 27 to 34. If I were to find the difference by subtracting successive terms, I'm going to see that there is a difference of 7 consistently through this pattern, which means that my common difference is 7, and you can complete the pattern. The third one. Okay, I'm getting into -3 to 2, 2 to 7, 7 to 12. And again, by subtracting, I'm going to see the common difference is 5. And again, you can continue that pattern, and we'll reveal the answers in class. Last one. This time the numbers are decreasing instead of increasing, so that means I'm subtracting something. And again, by subtracting successive numbers, I'm going to see that I'm going to continually and repeatedly subtract 11. So my common difference is a -11. And you can follow that pattern. Another topic that we talked about was direct variation. Okay, direct variation. The model of direct variation is y is equal to kx. All right, and we're told that x and y vary directly when x is 10 and y is 5. We can find this constant of variation. The constant of variation is also called your slope. So we'll take what we know, and we know that y is 5, and x is 10, we're looking for k. We'll do one inverse operation, we'll divide, and we'll simplify because we get k is equal to 5/10, and we would like to simplify that. K is equal to 1/2. So now that we know what the constant of variation is, we write the equation by writing y is equal to 1/2 times x. We can now find any value of y when given x. For example, to find the value here of y when x is equal to -4, well, we'll just substitute in the -4 and simplify, and we'll find out that y is equal to -2. So when we get this input of -4, our output is -2. And that's a little bit of direct variation, and we also know that direct variation, when graphed, passes through the origin. So my first point will go directly on the origin, and my k is also my slope, so I'm going to go up 1 and over 2 and graph. Perhaps we should do one more. Let's take another example when x equals -3 and y equals 12. Go to the model. Y is equal to kx. We know that y is 12. Now there's a little delay today in my searching for k, and we know x is negative 3. We'll divide both sides by negative 3. And we get k is equal to negative 4. Once again, we write the equation y is equal to negative 4x. And we may be asked to graph. So we start at the origin. And our slope is the same as k. So if k is equal to negative 4, then m is also equal to negative 4. So from there, we'll count down 1, 2, 3, 4, and over 1. And there is my graph. And that's your direct variation. Today, I want to move on to talking about slope-intercept form of a line. Y is equal to mx plus b. M represents my slope, and b represents my y-intercept. So let's just start by identifying these key pieces of information. I'm giving you these equations in what we call function form or slope-intercept form. Y is equal to mx plus b. It's very easy when it's in this form to identify your slope, which is just the number in front of the x term there. It is not the variable, just the number. And then my y-intercept is 5. In my second, again, m is just a number. It's a ratio of rise over run is 5. My y-intercept, which is b, is 3. In my next one, my slope is 2 over 3, 2/3. My y-intercept, negative 4. So you should be able to identify your slope and your y-intercept. You should also be able to be sure your equation is in the right form so that you can do so. Since we know how to write something or look at an equation in slope-intercept form, we're going to go back and graph. And before we get to that graph, remember these are our 4 basic types of slope. Our positive uphill line, our downhill line that's a negative slope, the horizontal line which is a 0 slope, and the undefined line which is the vertical line here. So there are our slopes. And again, I said we were doing a little bit of a review today, so that's why I snuck this one in here. So now on to the quick graphs. We'll come back to this. All right, quick graphs with slope-intercept form is my main focus today. I give you the equation y is equal to, and again, I don't really like writing it that way, the 2/3 x plus 2, where I can identify my slope and identify my y-intercept. Simple directions. Start with your y-intercept. That's a point on the y-axis. B is 2, so I'm going to go up and put my first point at 2. I'll now use my slope, rise over run. It's a positive 2/3. It's telling me to go up 2 and over 3. 1, 2, 1, 2, 3. All you need is 2 points. There's your line. Now technically I can keep going and do several points just to get the flow of the line, but remember you only need 2 points to graph a line. Let's do another example or two. In my next one, again, I like to identify my slope. My slope is 3 over 4 ratio. My b or y-intercept is negative 2. Start graphing with your y-intercept, negative 2. Go up 1, 2, 3, and over 1, 2, 3, 4. And connect the points. Slope positive, it goes up and over. My next one has a negative slope, a negative 2, and my y-intercept is 3. Now remember, a whole number can be written as a ratio by placing it over 1. Where did we start? With the y-intercept, 1, 2, 3, point on the y-axis. This time my slope is negative. It's going to tell me to go down 2 and over 1, down 2, over 1. If I wanted to, I could do that repeatedly, but like I said, you only need 2 points, and there's your graph. So if you recall, in our model of direct variation, we started at the origin. On these, we start at our y-intercept, and then we use our slope to graph additional points. We'll do more examples in class.